Hello, students. Got a couple homework questions coming to you today, so I'm going to jump into that. These are from 8.1. And the first question is for B. Okay, so let me grab my little tablet here. Let's see, we got 4B and D. So B is in boy, D is in dog. All right, well, as you look at this one, again, this, like right off the bat, it almost seems like this question was written intentionally to be confusing. However, there's a goal behind this type of question that I hope to be able to kind of convince you of. But let's take a look at it. I'll get a little bit of white space here. All right, there we go. Okay, so we're going to look at B. B is in boy first. Okay, so right here. Oop, that is a little thicker than I want. There we go. So the amount of money in a jar, so it's in cents. That's the first thing we need to know. It's not in the number of coins, it's just the number of cents. So we have some nickels, some dimes, and some quarters. So before you start anything, right, what you could say is the amount of money is equal to, again, I don't know anything else about that. I could just say some nickels, some dimes, and some quarters, right? For every nickel that I have, it's the amount of cents. Well, every nickel is worth 5 cents. So if I just had a group of nickels, this would be the expression for nickels turned into cents. And then dimes. Okay, well, dimes are worth 10 cents. So 10 for every D. And I'm using lowercase there because I guess I could use lowercase the whole time, but lowercase d, my uppercase D, when you look at it, sometimes it looks like a 0. So I don't want to make that mistake where someone says, wait, why do you have a 0 in there? So that's the reason why for that. Okay. And then quarter. So quarters are worth 25 cents. And so there we go. So what I have is I have an expression for how much it is in cents. What you're going to notice, though, is that creates 3 variables. So what we do the rest of this is we're going to try to say, I wonder if I could rewrite that so there's just one variable so that I can just plug that in and I get the total number of cents. In that case, we need to kind of have relationships between the variables. So let's see if we can figure those out. Okay. So it says there are 3 times as many quarters as nickels. Okay, so let's just kind of sketch that out. So 3 times as many quarters as nickels. So 3 times as many quarters. So if I had 9 quarters, right? That's 3 times as many quarters as there are nickels. Okay, so if I had 9 equals quarters, then nickels had better be 3. Because you'd say, oh, there's 3 times as many quarters as there are nickels. That relationship, though, in terms of algebra, could be done by saying, well, quarters is 3 times n. Okay? Which I know looks a little weird, but what we're saying is n, there's less n's, there's more q's. So we multiply the n's by 3 to get the number of q's, 3 times as many. And it says there's 4 times as many nickels as dimes. So 4 times as many nickels as dimes. So let's just get an idea here then. So if I had, I don't know, if I had 40 dimes, right? And there are 4 times as many nickels as there are dimes. So there's more nickels. So this would be 160 would be my nickels. Okay, so in this case, what I would say is that n would equal, what would n equal? 4d. Okay. Now, look back at the top. See what I had up on the top? I had nickels, I had dimes, and I had quarters. So wherever I see an N, I can replace it with this. Wherever I see a Q, I can replace it with 3N. So what I end up doing is I have 5N plus 10D plus 25 of Q's. But remember, Q's are 3N. So I get 3N for that. Now, anytime I see an N, Look down here at the second one, n is equal to 4d. So m is equal to 5 times 4d plus 10d plus 25 times 3 n's, but every n is 4d. Okay? And that is how you can do that. Now you can just simplify a little bit. Turns out all of these, like 5 times 4 is like what, 20d plus 10d plus, okay, now I'm going to do a little bit from what we did last term of, being smart about what we do here. So 25 times 4 is 100. And 100 times 3 is 300. So that's how I'm going to get that piece by doing it 300d. And that should be able to give me, what is that, 330d? So there's my final answer. Okay. So if you were writing this out as your kind of final answer, you'd have 330 times d, but just think of what we're measuring. We're measuring cents. So that would be my final answer, 330d cents. Okay. Now again, the first part up top is probably the most natural. Think about how many nickels, how many dimes, how many quarters. I just put those together, which is fine. Just start that way, right? There's not, in my mind, you're going to make more mistakes if you just try to jump down here to get the answer. It's easier to say, let me go one step at a time. Let me write out what I know, and then try to take the other clues that they might have given you and write those out. And you'll notice I put an example on the side to kind of help me see how to translate that into an equation. So that was B, and then D. Okay, so D is the amount of bacteria after N. Okay, so let me clear everything here, and we'll just get a fresh piece going. Okay, I'll do blue for this one. So I'm going to do D. That was the other question. The amount of bacteria after N minutes, if the initial amount of bacteria is Q and the amount of bacteria triples every 20 seconds. Okay, so, and this says after N minutes. Okay, so let's think about that then. Okay. So I need it after N minutes. So let's start. The initial amount is Q. So I want you to think about that. So we start with Q. And after 20 seconds, it triples. So again, this is 20 seconds. I'll write that down in a second. But I triple. So I have 3 times Q. Okay. So let's put that down. This is 20 seconds. The next 20 seconds, again, what happens to that bacteria, right? Well, every 20 seconds, it triples. So I need 3 times what I had here. So I'm going to have 9Q. All right. And again, now I go with another 20 seconds, right? And so now what happens during that next 20 seconds? Well, every 20 seconds, it triples. Now I have 27 times what I started with. Okay, and that's why when you kind of pause for a moment and say, well, wait a minute, 20 seconds, 20 seconds, 20 seconds, that gives me 60 seconds, which is 1 minute. So after 1 minute, so if I kind of condense this down to my new 1 minute piece, I would start with Q, then I wait 1 minute, and I'd have 27 times that amount. And then if I wait 1 more minute, I'd have 27 times that amount, right? Which would be 729Q. And the next one I'd multiply by 27 again. So what I want you to see is this creates, how do I get from one term to the next? I am multiplying by 27. That makes this a geometric sequence. We're multiplying by the same thing each time. So the amount of bacteria, would equal, and what does it say? Oh, it says write an expression. I guess I was writing an equation to say the amount equals, but when he just says write an expression, I don't need that. I'm just writing what it is. So after Q. So after 1 minute, I'd have this. After 2 minutes, I'd have this. So the terms right here would be start with Q, because that's my first term, times 27, which is my common ratio, raised to the n minus 1. And that comes from the geometric sequence. So the geometric sequence was this. The nth term is a1 times r to the n minus 1. So I'm just using that because I noticed every minute it's multiplying by 27. Okay. There we go. That's it. There you go. So there's D. That kind of hopefully helps kind of guide. Again, take it one piece at a time. If it's like, wait, this is seconds, that's minutes, that's okay. Write it out. You know, when in doubt, write it out. All right, let's jump forward a little bit. 13. Try to do part A, the first term and the difference. Find the first term and the difference. Okay, the 100th term is 28. The 200th term is 100. All right. So if we're doing, and I think there's one similar to this in part A. So let's check. See if we're on the right track. Actually, let me jump back. Let me check the part A one, because I thought there was one like this in part A. Wasn't there? I thought there was. Okay, let me just erase that real quick. Yeah, here we go. First term is 27, 200 term is 98. Okay. So let's yeah, we can do either one, honestly. So why don't I do this one so you can practice with the other one. Let's just see how we do. Okay. All right. Find the first term. Okay, I'm looking for the first term and the common difference. So the 100th term is 27. Okay, so if you need to, come off to the side, just write that down. The 100th term is 27. Now, there's a couple ways you can do this problem. One way is to go back and say this is an arithmetic sequence. So you could represent this as the first term plus n minus 1 times the common difference. Well, I know n is 100, so that would be 99 common differences. Okay. And then, so I could do that, and I could come down here and I could say this is a 200, and the 200 term is 98. And what is that? That's the first term plus 199 common differences. So I could do that, and this would be kind of the approach. Now, what that means, if I kind of tie this together to what we kind of done algebraically, is 27 is A1 plus 99 Ds. And 98 is A1 plus 199 common differences. And then using the techniques that we've seen, we have two things that are equal, so we could actually subtract these. Okay, so for example, 98 minus 27 would be 71. A1 minus A1 would just be 0. And 199D minus 99D would be 100D. So now if you were going to solve that, you could actually now go through and solve that and get that, oh, 71, oops, 71. Not sure what happened there, sorry. 71 is 100 common differences. So if you wanted to finish this one up, just divide by 100. And you're good to go. 0.71 is equal to the common difference. So it says find the common difference. I now have the common difference. And then you could plug that back in up here or into any one of these equations to find the missing piece. Let's take a look how to do that. So 27 is equal to A1. I'd plug it into D. I drew the arrow to A1. I meant to draw it to D. Sorry about that. A1 plus 99 times 0.71. And then we just solve. So we multiply 99 times 0.71. Okay. Let's see here. 99 times 0.71 gives me 70.29 is equal to That's the A1 there, and that's 27. Now just subtract on both sides, because that's our property of equality from chapter 7, and that leaves you with A1 by itself. So you get 70.29 minus 27, and that's 43.29. So there's your first term, and there's your common difference. Now, if you want to check yourself, and I encourage you to check yourself. So if you said, okay, my general term then would be, and that would be a negative. I don't know why I put that in. Negative 43.29 plus n minus 1 times 0.71. If you want to simplify that, you can. Okay. So let's see here. Let's do a little simplifying of that if we can, just to make it look maybe a little bit neater. Distribute across 0.71 times n minus 0.71, and combine the negative 0.71 with the negative 43.29, and you should get negative 44 plus 0.71 n. And that is how we can find any term in the sequence. So if you wanted to find the 100th term to check yourself, you can plug in negative 44 plus 0.71 times 100. And if you do that, plug it into your calculator, you will get 27. And if you plug in 200, you will get 98. So it does check with the initial conditions that we had. And that's one approach to doing this. This is a very algebraic, very abstract approach. And so for many of the students you might see, this might be way over their heads in terms of what you'd be expecting them to do, especially with 2 equations and 2 unknowns. So let me clear that all and kind of say, well, what's another approach, Scott? Is there another way I could do it? And the answer is yes. It involves algebraic thinking. And so if you kind of get the idea in your mind, it actually comes out, you're like, oh, okay, that's not too bad. So here's the idea. If we think about this, right? Right, 100th term, 200th term, right? So I have a first term, right? And so let's see here. Let me just start this out. So the 100th term is 27, right? And the 200th term is 98. So what I want you to do is I want you to think, how would I get from 27 to 98? Well, if 27 was the 100th term, the next term would be the 101st term. And whatever I added, the common difference, I would just combine. I'd add the common difference. That would give me the next term. I'd add the common difference again. 27 plus 2d would get me to the 102nd term. ... Well, I want to get to the 200th term, so I need to add 100 common differences. So to get there from the 200th term, we know is 98, but notice I'd have to start at the beginning and I'd have to add, this would be 27 plus 100 common differences, and that's going to get me to 98. So what you can do then is say, aha, I've got it, which is, how am I going to do this? I could just say 27 plus 100 common differences is going to land me at 98. And from there, I can subtract 27 and divide by 100, and you are going to end up, you're going to love this, with 0.71. There you go. And then you could say, well, how do I get to the first term? Well, if I went up 100 terms to get here to the 100th term, to get to the first term in the sequence, I have to go down, not 100 of them. I only have to go down 99 terms. So what I could do is I could say, well, I'll just take 27 and take away 99 common differences, and that will get me the first term. So the first term in this case is the 43.29, negative 43.29. So 27 minus 99 times 0.71 is 43.29 in the negative. And there's the exact same thing we had from the previous problem. To me, I think this approach can be a little bit more intuitive. I think sometimes the algebraic approach, if one, if you're not familiar with it, and two, if algebra may not be your favorite topic, is it becomes cumbersome. Not that it's wrong, it just becomes like a little overkill. So this is the approach. Here's my first term, and there's my common difference, and I solved the problem. And I didn't have to go to those kind of big fancy pieces. I just looked at what does it mean to be a sequence? Add 100 common differences to get here. Oh, well, that's a difference of 71. Yeah. So divide 71 by 100. To go down, right? I mean, technically, you could just go down 71, which would not get you to the first term. It would get you to the 0th term if you just go down 71, which is kind of the negative 44, right? That's how you get there. And then say, oh, let me just go up 1 from there and add 0.71. And that's how you can get here as well. So a couple different techniques. I hope that one of those does click with you. Okay. Let's see here. Oh, and then one of the MCs, MC2B. Okay. Prove this is true for every arithmetic sequence. Got it. So you're trying to prove something is true for everything. If you're trying to prove something, remember the proof requires us to show without a shadow of a doubt that it always works. And so if we are doing that, then we need 7 consecutive terms, but they need to be general. So think about it. If you were picking terms, right? You're saying, okay, let me pick 7 consecutive terms. So like 2, 3, 4, 5, 6, 7, 8. Let's see, 1, 2, 3, 4, 5, 6, 7. There's 7 consecutive terms. What is the connection between them? What do you notice? How do I get from one term to the next? Okay, you notice, hey, I always go up 1. So I could have started with 13, right? 13, 14, 15, 16, 17, 18, 19. There's another 7 terms in a row. And if I check the average by adding them all up and divide by 7, in this case, I get 5. If I do the same thing here, I get, let me pull arrow, then I get 16. Yeah. Okay, so the question is, prove that this is true. Well, if you want to prove it, don't start with an actual number. Hold the place so that anyone looking can say, well, what if I picked a different number? And you can say, doesn't matter what number you pick. So instead of starting with 2 or 13, to prove this, you're going to start with n. What would be the next consecutive number after n? Remember, the number after 2 was 3, but how did we get there? You could rewrite this as 2 plus 1. So we're going to write our next number as n plus 1. And that way, hopefully, you can see if I picked 13 to be n, then n plus 1 would be 14. And the number after that, 15. And the number after that, 16, right? And so it's just I keep adding 1 more to get to the next term. N plus 1, n plus 2, n plus 3, n plus 4, n plus 5. Let's count how many numbers though. 1, 2, 3, 4, 5, 6. There's 6. So I need 1 more, n plus 6. Okay. This is your sequence. And what do I need to do with it? I need to check that the average is supposed to equal the middle term. All right, well, go down now and find the average. How do I find the average? It would be to add all of these up. Okay, n plus 3 plus, and you can keep doing that. I don't know if I'm going to write it all out, but you write them all out. You want to divide by 7. That's how you find the average. All right, I'll add them all up. plus n plus 5 plus n plus 6. Okay, so if you add them all up, combine your like terms, right? You notice there's a whole bunch of n's. How many n's are there? Then there's a whole bunch of numbers. Well, add them all up. How many numbers are there? Okay, and when you get that, you're going to be dividing by 7. So my tip for you as you prove this is to use that F word. Not that one. Factor. So the distributive property backwards. I'll bet you're able to factor out a 7 from each of the pieces on top. And then when you refactor it, use FLOF, the fundamental law of fractions, to simplify your fraction. Now, some of you may not call it FLOF. You may just call it canceling or simplifying your fraction. That's fine. But there's a property behind it, and it is this fundamental law of fractions. And then simplify that. Yeah. And at the end of the day, if you did this correct, when the goal is it's supposed to equal the middle term. Well, let's see here. Middle term would be 1, 2, 3, 4, 5, 6. So go in 3, go in 3. So the middle term should be that. So if you're able to show that when you do this process and you divide by 7 and then you simplify, if you're able to show that you get n plus 3, you have now demonstrated that no matter what number they start with, once they make a sequence of 7 consecutive numbers, you have shown that the average of that group of 7 numbers is always going to be the n plus 3. The middle term. So there you go. So keep that in mind. Again, if you're trying to prove this to somebody, it's so tempting to come and just say, okay, give me a sequence of 7 numbers. And they give you that sequence. And then you say, aha, look, it works. And they're like, oh, okay. But all you've done is shown that it worked for that one sequence. You'd now have to go do, well, what if I picked 14 to start with, right? What if I picked 27 to start with? What if I picked negative 100 to start with? And the reason why we choose it with variables is that people can put in whatever number they want, and you get a chance to see that it doesn't matter what number they choose. That's where the variable comes into play, that it will always work. And that is a pretty cool thing about math. So hopefully that gives you what you need as you go through the homework. If you have other questions, please let me know. I can meet you in person on campus, or I can certainly meet you on Zoom as well if you prefer, or I can do a video like this. All right, hope that helps. Off you go.